Hey everybody, this is going to be a walkthrough on how to get through homework 2, but it's also set up to prepare you to do some calculations for the exam. So like we begin every class, when we're using R, we're going to create a directory or folder on our desktop where we can put all our data and plots and things and let R know this is where we're going to be working from. So first, right click, new folder, create that new folder. And you want to give it a name that is related to the project that you're working on. So if it's an exam, write exam. If it's homework, you might want to specify which homework it's for. So here we're going to call it hw2 for homework 2. And you'll see that nothing's in there. Okay, next, navigate over to the course website and locate the homework assignment homework 2 and download those files. The best way to download those files and put them in the homework 2 folder is to right click on them and select save link as. So right click, save link as, we're in the desktop, and then homework 2, and we'll save the R code, example 2, our homework 2 example code, and then the homework 2 document. So save link as, save that in there as well. Cool. So now we are done with everything on the website. So I'm going to turn off Wi-Fi here so I don't get any interruptions. So now we have our two documents. Now let's open up this example 2 R code, or homework 2 example R code. And this is basically what you'll be doing for the homework, using different data sets. Anytime we're working with R, we have to first, or in no particular order, you set your working directory and call your required libraries. The only library that we need for this assignment is the mass library, and we have to obviously set our working directory to tell R this is where the data exists, this is where I want you to save my plots, all of that good stuff. So we'll begin. I'm going to work out of a new R script because it's easier for me to explain what I'm doing than just showing you the existing script. So first, let's do the set working directory. So this is to tell R this is where the data exists. Set WD is the function, followed by parentheses, the left parentheses, and the quotation marks. And inside the quotation marks is where you're going to locate or give it that location. It should look something like users, your username, desktop, because that's where we save the folder, and then the homework 2 folder. For me, it's going to be a little bit different. Okay, we'll go in, let's go back to our desktop, and you'll notice that there's an easier way to find the location of the desktop or that folder. If you already have documents in that folder, then you can right click and select get info, or on PCs you right click and select properties, and it'll show you the actual location of that file, homework 2 example code, inside the folder that you're interested in. So it says hard drive, users, my name, desktop, and homework 2. Because we're specifying a file inside the folder we want, it'll tell us exactly the folder we want, so we can just copy and paste this over. For PCs, you do the same thing. Highlight a folder in your homework 2 folder, or highlight a file in there, right click, click properties, and then highlight or copy and paste the location. So I'm going to copy this like I just did, go over to my R Studio, and then select paste. And there we go. There's my working directory. For PCs, yours might look something like C drive / backslashes. They'll look like backslashes like this. However, as I've mentioned before, R prefers the / that are common in Mac. So you have to go through and change these all to /. Right? And for Mac, mine is going to not include the C drive, so it's going to look like that. Okay. So now that I have this working directory, I'm going to go ahead and run that and make sure that it functions correctly. And it does. We didn't get an error message down here. It just works perfectly. And to double check, we see that in the top of the console window it's a desktop / homework 2. So it's telling you that's where you are. that's the folder. So next, like I said before, we have to specify our libraries, and we only need the mass package. So we specify mass there, highlight that, run it. So we're already set up. So now let's go back to the folder here and open up the hw2 PDF. So if we open that up, we'll get a sense of what we have to do for this assignment. So 3 problems in R, covering chapters 6 through 8. And lastly, I say remember to append or copy and paste your R script as the final page of this assignment. So we'll talk about that when we get to the end. So first, this problem 1 deals with the normal distribution. So I asked you in the first section, using any mean and standard deviation, plot a normal distribution using n equals 100 cases, and then show the plot in your homework. The second one says the same thing, but instead using n equals 10,000 cases, show the plot, and then finally comment on the differences between the 2 plots. So we can do that. Let's go back over to R, and I told you, or I mentioned this in a few classes ago, that to create a data set, randomly to plot normal distributions in R, we usually need normalized data. And to get normalized data, R has this nice function called rnorm. And rnorm is a function that randomly generates normally distributed data. That's why it's randomly generated normal distributed, so rnorm. Rnorm has 3 arguments. Those arguments are number of cases is the first argument, comma, second argument is the mean that you desire, and then the third argument is the standard deviation that you desire. So if we wanted to run on for our first problem, or the first section of that problem, we have a specified number of cases, and that's 100, with any mean and any standard deviation. So if we wanted to run this correctly, it would be rnorm, number of cases is 100, and let's randomly select, I'll say a mean of 5 and a standard deviation of 2. Cool, now we can highlight that function and run it. And look, in our console window we have the data generated from case 1 to case 97, 98, 99, 100. So 100 cases. However, if you remember, to do anything with these data, we have to specify it or call it an object. We have to move those data into an object. To do that, we use the object identifier, or object symbol, which is assignment operator. That's what it's called. So we have to assign an object name to this, which is a kind of pointer, which is a left caret and a dash, and then the object name. So in this case, I want to call our norm, I'm going to call it data1. Just, because that's a name that I'm used to, so I'll call it data1. Now, I'll run this, and I call this because I want to use this data. If I want to run a plot on it, then I have to call it, give it a name, so I can use it at a later date, probably 2 seconds later. So I select this, run it, and now it didn't show me all the data. However, if you look in our environment, data1 is a new set of values. It's a bunch of numbers from 1 to 100 numbers, and it lists all the numbers. Cool. Now, the next step is to plot these data, to plot this normal distribution. And to do that, we use the nice function called hist. It's a histogram. Create a plot of whatever data you throw at it. So in this case, we will plot data1, which is our randomly generated, normally distributed data. So we run hist, and there we go. We get a histogram of those data. It looks pretty normal to me. So to save this, you go up here to export in your plot window, click on that, click on save as image, and you'll notice that it's located in desktop/hw2 folder, so you're good there. And I would change this name to something that you can remember, so like plot1. So after you do that, save it. It'll show you what it looks like, and then you can close. So that's the first step. The second step, I ask you to create randomly generated or normal distribution using 10,000 cases and any mean and any standard deviation. So, like our last one, we use our norm. First argument is the number of cases, which is 10,000. Any mean and any standard deviation. Just to be consistent, I'll use the same mean and the same standard deviation. And again, if I want to use these data at a later date, if I ever want to use it again, I have to throw it into an object. And to do that, we use the assignment operator again and assign a name to it. I'll call this data2. And this can be any name you want. You can call it norm1 here and norm2 there. You can call it data and data1. You can call it whatever you want. But whichever name you call it, whatever name you give to that object, you have to be consistent. You have to use it later. So if you called this norm, then here it should say hist norm. Same thing for this. So we'll go down here and then run a similar plot for data2, which is our second data set. So I'll highlight both of these. It'll create the randomly generated, normally distributed data. It did, from case 1 to case 10,000, and then I plotted it already, and here's the new plot. So in a similar fashion, save this image under export. I'll call this plot2. Again, it's saved in the homework 2 folder, so you're good. And then I click save. It'll pop up and show me. And there. Alright, so that's those two sections of question 1. And the third question is to comment on the differences between the two plots. So I won't give you any comments there, but I'm sure you can guess where it's going. Here, I'll erase this because we're done with that, and I'll just throw a comment in here to remind myself that this is problem 1. Okay. Alright, next we'll move down a little bit, a couple of spaces, and then I'll say we're going to work on problem 2. Okay. So for problem 2, let's open file again. We'll see we're working on sampling now, which is chapter 7. So I say using the US arrest dataset in R, take 3 random samples using n equals 20. This is your sample. Okay, then we'll calculate the means and standard deviations for the murder variable in that sample, not in the US arrest data, but in the sample. So we do that, and then we comment on the differences between the 3 means and the 3 standard deviations. Do they differ? Why or why not? So first, we'll deal with specifying the US arrest data. So if you simply type in US arrests, R comes with this nice data set. They come with R comes with a lot of data sets, and US arrests just happens to be one of them. So if you just simply type out US arrests and run that, it'll pop up with the data set. The data set itself is listed here. So murder, assault, urban pop, rape, in a bunch of different states. Now, if we go and try to type out US arrests, again, US arrest, I'll highlight this, and we'll see some information about the data. US arrests. This data set contains statistics in arrests per 100,000 residents for assault, murder, and rape in each of the 50 states in 1973. Also given is the percent of the population living in urban areas. So that's good. We know the data come from 1973. We know that it's for all 50 states, so we know that there are 50 cases across 1 year, and then each of these represents a rate of arrests. So in Alabama in 1973, there were 13.2 murders. People were arrested for murders 13.2 times out of 100,000 people. So for every 100,000 person, there were 13.2 murders. 236 assaults per 100,000, 21.2 rapes per 100,000 people, and about 58% of the population lives in urban areas. So this is across 50 states. So we have those data. But again, much like everything we do, to use these data, we don't want it just to pop up in our console window. We have to give it an object name. So we can give it a new object name. So use the assignment operator, give it a new name. I'm going to call this arrests. So now we'll run that, and now if we see our environment window, we see that there's a data set here called arrests with 50 observations and 4 variables. So it basically just took these 1, 2, 3, 4 variables across 50 cases, 50 observations, and threw it into a data set called arrests. So now we don't even have to do anything with US arrests anymore. We can just specify arrests every time we want to look at something. So if I wanted to look at the murder variable, arrest, and I'd specify murder. Okay, murder. So I can look at that, arrest and murder. I'll run that, and it gives me all the data for that arrest, murder. Or I'll look at assault. Run that, and it'll give me all the data for all the assaults by each case. Remember, we use every time we want to specify a variable inside a data set, we use dataset name, $, variable name. Now we'll be working with the arrest data. Now we go back to the example code to see how to take samples. So we've done the first step, is creating a new object called arrest that we can use at a later time. Now we'll go to our example code, scroll down to 2A, where I say take 3 random samples, and we're going to create samples. Now I'll go ahead and copy this. R has this crazy bit of code that will allow you to take samples from a data set. So I'll give you a general, let me clean this up a little bit, data set name slash, okay, and data set name and number of cases. So here's the bit of code. It goes dataset name, so what's the dataset you're working from, and then you use this bit of code called sample, and it says from the first row to the last row in a dataset name, take a random sample. And then it needs to specify how many cases you want in your sample. So you specify a number of cases, and then replace equals false. And what replace equals false means is you're going to go in, randomly pick somebody from the population to put in your sample. Now, the next time you go in, and so you've selected one case, say we selected Alabama in the first case, I don't want this bit of code to throw Alabama back in because there's a chance that I could pick Alabama again. So once it's taken out and put into the sample, I don't want Alabama thrown back in. So that means that it's not going to be replaced, and instead it will pick from the next 49 to select this new case. So to run a random sample, I ask you, let's see, I say to take 3 random samples of n equals 20 from our data set. So first off, we've already named our data set an object, so we have our data set name. It's not US arrest, it's just arrests. That's what we're pulling from over here. So data set name is now arrest. And here, so we don't change sample, we don't change 1 to n row, we don't change replace equals false. All we change is the dataset name and the number of cases. So dataset name here is going to be arrests again. And number of cases, I ask for an n equals 20, so you change that to 20. And that's your code for creating a sample of 20 from the arrests dataset. So I can highlight this and run it. Great. You'll notice that if you counted all these out, there are 20 cases. I'll run a different one, another 20 cases. So this one starts with Wyoming, Pennsylvania, Alaska. Up here it's Oregon, Minnesota, Oklahoma. Okay, randomly generated. However, to work with these, just like with everything else, we have to throw it into an object, give it a new name. So instead, I will turn this into an object using the assignment operator. Call it sample1. So I'll highlight all of that and then run this bit of code, and after I run this bit of code, you'll see that it says sample1 specified there. And here we see that sample 1 is, unlike the arrest data, sample 1 is 20 observations using the 4 same variables. So we don't have to change anything here. We just highlight this and copy it 3 times. Copy and paste it 3 times. Because it's randomly generating a sample, you'll have randomly selected cases in each sample. So to create 3 different samples, you just run the code over and over again. So instead, I'll just give them different names. So we have sample 1, sample 2, and sample 3. So I'll go ahead and highlight all of these and run them. And again, we have 3 random samples. Sample 1, sample 2, sample 3, with 20 observations each. Now if we look at each of these, we'll see that they're slightly different. So in sample 1, so I clicked on each one of these and to compare. So sample 1 begins with Wisconsin, then it goes Wisconsin, New Jersey, Montana, Delaware. Sample 2 is New Hampshire, Maryland, Indiana, New Mexico. Sample 3, Pennsylvania, Ohio, Hawaii, and Nevada. So you see that they're different across each, because each case from the arrest data of 50 cases, each one that's put into the sample is randomly selected. So Wisconsin was selected first, then New Jersey, then Montana. For sample 2, New Hampshire was selected first, then Maryland, then Indiana. Sample 3, same thing. Pennsylvania was selected first, then Ohio, then Hawaii. So you see how they all differ. Now I'm going to close those, go back to my code here. So we have my 3 samples, and then what I ask is, what I ask you to do is calculate the means and standard deviations for the murder variable in each sample. Okay. So now we're dealing with samples. I don't care about the arrest data per se anymore. For this problem, I'm only concerned with the murder variable for sample 1, the murder variable for sample 2, and the murder variable for sample 3. I want you to calculate the means and standard deviations. So, like we've done many times, we can calculate those, right? There's a function. Mean is the function for calculating the mean, and standard deviation, or SD, is the function for calculating the standard deviation. But we have to specify what variable we want. So we want the murder variable from each sample and calculate the mean for those. So for sample 1, I'm going to say specify the murder variable. And we do the same thing for the standard deviation of sample 1's murder variable. So sample 1 murder. Okay, now we can calculate the mean and standard deviation for the murder variable in sample 1. But because we're interested in comparing the means across sample 1, sample 2, and sample 3, and comparing the means across the standard deviations across sample 1, sample 2, sample 3, we have to have this for across all 3 samples. So I'll hit enter here, copy these, and paste it 2 more times. Here I'm going to take the mean of sample 2's murder variable, and here I'm going to take the mean of sample 3's murder variable. And then the same thing for standard deviation. Copy and paste it 2 more times. And we're going to take the standard deviation of sample 1's murder variable, sample 2's murder variable, and sample 3's murder variable. And we will compare all across these 3. So I highlight the means for sample 1, sample 2, sample 3 murder. Calculate those, and we see that the means across the 3 samples are different. We do the same thing for standard deviation. Standard deviation for sample 1's murder variable is 3.34. Sample 2 is 4.75, 4.53 for the second one. Now, the important thing to know is, again, these samples are randomly generating these. This code is randomly generating samples. So, although my mean for sample 1's murder variable is 6.14 and sample 2 is 9.09, because mine were randomly generated, so are yours. So our numbers aren't going to be the same. However, I do want you to report the numbers that you do get. So, for instance, I may, in my sample, it may have randomly selected the first 20 cases. For yours, it may have randomly selected the last 20 cases, and because of that, will our sample means be the same or different? And that's really what I'm trying to get at with this, is showing how samples across the same data set, when you create different samples, how they are the same or are different. And this has a lot to do with sampling and sampling error. So let's go back to this. Calculate the means of standard deviations and report them, and comment on the differences between the three means and the differences between the standard deviations. Do they differ? Why or why not? Okay, so that's problem 2. Now problem 3. Create a comment, problem 3. Alright, let's go back to problem 3. Problem 3, we say the first part is to report the following formulas: the z-score formula, the 99% confidence intervals formula, and the standard error of the sampling mean of the sampling distribution formula. So you can write those out or type those in Word. Okay, so using the arrest data set in R, I want you to calculate the mean, standard deviation, and the sampling error of the mean for the assault variable. For this one, we want to calculate the mean for the US arrest data. So again, you don't have to do this, but we know that this is the US arrest data, and I'm going to call it something else. So I'm going to call it arrests. I know that this arrests data already exists, and if I do this and run this, it's just going to overwrite that with the same data set. So just for consistency, I'm showing that again. So now we've created a new object called arrests, which was the same object as before. So with this US arrest data, I want you to calculate the mean and standard deviation and sampling error of the mean for the assault variable. So to specify variables, so first we're calculating a mean, right? So mean of some variable, and that's the assault variable. So we have to specify first the data set, and then the assault variable. We have the assault variable, right? And then next I say the standard error, or the standard deviation, and that's going to be SD. Arrests is the data set, and then the assault variable again. And then for standard error of the mean of the sampling distribution, I have a bit of code in this. So to calculate the standard error of the mean, we know that it's going to be, let's copy this. The standard error of the mean is going to be the standard deviation of the variable over the square root of the number of cases in your data set. We know that standard error of the mean is equal to SD of that variable over the square root of n. However, writing these functions in R aren't very straightforward, which is why I've written it out for you. So to calculate the standard error of the mean, I do calculate the standard error of the assault variable. So I do standard error of the assault variable divided by, and we have to do square root of the number of cases. So square root function here is square root, that's how it's typed, SQRT, and then it's going to be the number of cases in my data set. So to do the number of cases in R, you have to specify in row. And that says the number of rows, the number of observations, the number of cases in your data set. Then you have to specify which data set. So again, our data set here is arrests. Okay? So we're saying here, first, take the number of cases in my arrests data and square root it. And that will be the denominator. On the numerator, we have the standard deviation of that variable that we're interested in. And we know that it's really, instead of sigma over square root n, it's s sub y bar. And that's because, or s sub y, we can use if we have enough cases in our data set, we can use the standard deviation of our sample to calculate the standard error of the mean, because we assume with enough cases you're close enough to the actual population mean. So that's why we use the standard deviation. So I'm going to clean this up a little bit. I'm going to say put standard deviation, put that whole thing in more parentheses. Then for the square root, I'm going to put everything else, highlight that and type in parentheses. You'll see there, if you highlight that line and then type in the left parentheses, it will create a right parentheses for you. Okay? And then that's it. Okay, so now we can run this. We'll run the mean for the assault variable. We'll run the standard deviation for the assault variable. And then we'll run the standard error of the mean for the assault variable. Okay? They're all calculated. Great. Okay, sorry, I'll open that back up. Next I say calculate z-scores for the assault variable. Okay, to calculate z-scores we need to calculate z-scores we're going to create new scores for each observation. So across all 50 states they're going to have a z-score for their value. So this basically says how far from the mean is each state's number of assaults per 100,000 people. So to create a z-score we have to know the z-score formula, right? The z-score formula is z equals y minus the mean over the standard deviation, right? So we know how to calculate the standard deviation, we know how to calculate the mean, and y is just that person's score, that observation score. So what that means is it's going to say take Alabama's assault value minus the mean of all assaults over the standard deviation of all assaults, and that'll give a z-score for each case. So to do that, let's actually write that out. So it's going to be each case's assault variable. So assault arrests assault. So it's saying take everybody's assault, every state's assault value, and subtract the mean of assault. Arrests assault. Okay, so this whole thing says take the mean of the value for Alabama, value for California, and subtract the mean, because the mean is the same across all. The mean is 170.76, so it's taking everybody's value and subtracting 170.76. Then we divide that by the standard deviation of assault. So it's going to be SD parentheses arrests and the assault variable. Okay, and then we can go ahead and run this, and this will create a value for every state's assault variable. It'll create a z-score for every state's assault variable. But we want to use these, right? So we've calculated each of these. You can name them objects if you want to. I think it's important for you to name the z-scores an object. So I'll call this z assault z-score. And then I'll put the assignment operator there. So it's going to call it assault z-score. Or assault, actually I'm going to call it assault z. And I'll run that. So now down here we have 50 cases with and each has a z-score associated with the assault variable called assault z. Importantly, if you want to throw these data back in the data set instead of saving it as a separate set of values, you can make it into a variable. So To do that, like you specify variables in datasets, you just specify this as a new variable. So you're saying call this object, but instead put it in the arrests dataset. So you go arrests, $, and then assault z. Now you'll see that the arrests dataset up here is 50 observations with 4 variables. However, when I put this $sign operator there, it's going to say, actually, create this new object, but save it as a variable called assault z inside the arrests data. So I'll highlight this, watch over here, I'll run it, and now it's 50 observations with 5 variables. Okay. And we can open up the arrests data and see that we have the 4 variables: murder, assault, urban pop, and rape, and then assault z. And this is a z-score associated with the assault variable. We know that the assault variable mean is 170.76. So if somebody's assault is about 170, we have 190, their z-score is closer to what? 0. A z-score of 0 means that you have the mean value. You see that high scores, like 335, are way above the mean, and you can see that in the z-score. Z-score is nearly 2, so 2 standard deviations above the mean. So the same for all of these. You can go through and see 1.5 standard deviations above the mean, so on and so forth. 1.99, so nearly 2. So you can see that scores closer to the mean are closer to 0. Scores further away from the mean are closer to 2 or 3 or 4 standard deviations. Or the z-score is closer to 2 or 3 or 4. Cool. With that, we've thrown those data in, and then finally, we have one more thing. I ask you to calculate the 99% confidence interval for the assault variable. Okay. And here I would prefer if you refer back to the example 2 code. I have a CI bit of code. Okay. Here we go. So next, we're going to calculate the confidence interval. Okay. To calculate the confidence interval, we know the confidence interval is CI equals the mean, so mean plus or minus a z-score for a specified confidence interval, confidence level, times the standard error of the mean. Okay. We know we can calculate the mean of a value for a variable. We know we can calculate the standard error of the mean for a variable. We've done that here. That's the standard error of the mean. This is the standard deviation, and this is the mean. Okay? And we need a specified z-score value. So I ask you to calculate the 99th percentile. Right? That means that for the 95th percentile, our z-score is 1.96 based on those cutoffs, and a z-score associated with 99 percentile, or 99% confidence, is 2.58. So, to calculate the mean, the standard error of the mean, we're going to have to do mean of our assault variable for the arrest data. So arrests, assault, okay, the first assault variable, and we'll say minus, and then our z-score is 2.58. It's the one associated with 98 or 99% confidence, and then the SE of the mean. So we can just copy our SE mean code here, plug that in there. And because we're concerned with order of operations, we can clump these together. Okay. So we can run this. It'll give us, sorry. Oh, so we have to type in the star. And because I did minus, this is the lower bound, 140.35. I can copy that over because we needed the plus and the minus because we're interested in how low can the population. We want to know in our data we have a value, a mean for arrests, but we want to know how much the true population mean could fall within. So we say we'll calculate the mean and then plus or minus some score. So we have the lower bound and then we switch this to positive and that'll give us the upper bound. So the lower bound here, the upper bound here. And this tells us that we can be 99% confident that the true population mean of assaults that occur in the United States falls between 140.35 assaults per 100,000 and 201.17 assaults per 100,000. That's how you can calculate both of those values. Another way of doing that is using this list function. So I can take these values and say, instead of this, I'm going to throw a comma in here. I'll add another parentheses over here, one at the front, and then say the word list, and then I'll read them together. 140.35 and then 201.72 or 17. But that's another way of doing it, but the first way works as well. You list the minus, the lower bound, and plus as the upper bound. And now that's how you go through and do that homework assignment. And that is it. And then finally, I ask you to copy all of this and then paste it into a Word document. So you'll go through and answer the questions. For question 1, you'll show me the plots. For question 2, you'll give me the means and the standard deviations. For question 3, you'll list all the mean, standard deviation, and standard error of the mean. You'll run the z-score, and then you'll also tell me the lower and upper bounds for the confidence interval. Right? So you can Control A, copy that, and then in a Word document here, let's open up Word, and on the final page, so you'll say problem 1, problem 1, all your answers, problem 2, all your answers, problem 3, all your answers. So let's just keep going. Your answers keep going on separate pages, right? There we go. Separate pages, keep going, and then all of a sudden, you're done. So what you need to do is hit Command-Shift-Enter or Control-Enter or Control-Shift-Enter to start a new page, fresh new page, and then what you've copied from your code in R, your script, copy, and then paste that on the new page, Control-V. And there we have all of your code. And this is the typical practice for when you're running statistics to show the reader the code that you written through, the process of calculating all of these things. So if they wanted to run it themselves, they could do that. And if you have errors, they can point out where you have the errors. Alright, and go ahead and save that and turn that in online. Right, that is it. I am done here, and hopefully that clarifies what you need to do for the homework. Alright, best of luck, and see you on Friday for the exam.